Look at your hand, whatever shade it is. Every single one of your ancestors, going back 300,000 years, had dark skin. Not most of them, not the majority, all of them. Then something changed, and the thing that changed it was a star 93 million miles away that has expressed no regret about it whatsoever. This is the story of how your skin got its color. It involves cancer, pregnancy, Ice Age Europe, and farmers who accidentally rewrote their own biology without ever knowing it. Sit with that first fact for a second, because most people hear it and quietly assume it's an exaggeration. It isn't. Around 300,000 years ago, when Homo sapiens first appeared in Africa, the entire species was dark-skinned. There were no pale populations anywhere on the planet. Light skin in humans did not exist yet. Every ancient civilization you've read about, every cave painting, every mythology, all of it traces back to one founding population that looked nothing like a large share of humans alive today. So something happened. Something powerful enough to reshape the appearance of entire populations across multiple continents, over tens of thousands of years. To understand what, you first have to understand what skin actually is. Most people treat skin like packaging, the bag your body came in. But skin is an organ, your largest, and one of its most important jobs is stopping ultraviolet radiation from getting into you. UV is the invisible energy the sun fires at Earth constantly. It breaks chemical bonds. It damages DNA. It causes mutations. Pile up enough of those in the wrong place and you get skin cancer. And the pigment that gives skin its color, melanin, is, in the most literal biological sense, sunscreen. Built in, always on. The more melanin, the darker the skin, and the more UV gets blocked before it reaches the DNA underneath. Dark skin isn't a look, it's a shield, which is exactly why in equatorial Africa, sitting under some of the most intense UV on the planet, evolution selected for it hard and fast. More melanin meant less DNA damage, meant longer life, meant more surviving children. Because that's all natural selection actually is. A very slow, very ruthless optimization algorithm running one calculation over and over across billions of organisms. Does this trait help you survive long enough to reproduce? If yes, keep it. If no, delete it. In equatorial Africa, dark skin was a hard yes. Every generation, every time. But UV doesn't only attack your skin, it attacks something inside you. There's a molecule called folate, a form of vitamin B9, flowing through your bloodstream. And folate is critical for the development of the neural tube in an embryo, the structure that becomes the brain and spinal cord. Without enough of it in the first weeks of pregnancy, often before a woman even knows she's pregnant, that structure can fail to close properly. Here's the problem. UV radiation destroys folate. It penetrates the skin, reaches the bloodstream, and breaks the molecules apart. So in a sun-drenched environment with no clothing, no shelter, and no shade, less melanin meant more UV, meant more folate destroyed, meant fewer pregnancies reaching term, which gives us not one but two completely independent reasons why dark skin was non-negotiable under the African sun. Melanin protected DNA from damage, and melanin protected folate in pregnancy. Two separate threats, one biological solution. So dark skin is a multi-purpose biological tool. It blocks cancer. It protects pregnancy. It has been field tested over hundreds of thousands of years. If evolution had a review system, it would be sitting at 5 stars. So why did it ever change? Somewhere between 70 and 100,000 years ago, groups of Homo sapiens began leaving Africa. Nobody called a meeting. Nobody announced a great migration. It was generational drift. A group moves slightly further than their parents, their children slightly further still, until humans had spread through the Middle East, into Europe, across Asia. And as they moved north, the sun got weaker. Not the sun itself. The sun remained exactly as indifferent and nuclear as always. But at higher latitudes, sunlight arrives at a lower angle. It passes through more atmosphere. Days are shorter, winters are long, the sky is gray for months. Instead of overwhelming radiation you need to block, you get weak, intermittent radiation you desperately need to absorb. And suddenly the skin that was perfect in Africa became a problem. for a reason nobody expects. Vitamin D, your skin is, genuinely, a solar panel. When UVB light hits a compound in your skin, it manufactures vitamin D. And vitamin D is not optional. It regulates how you absorb calcium. Without it, bones don't mineralize properly. In children, severe deficiency causes rickets, bones that soften and deform. In women, it softens the pelvis, which historically made childbirth dangerous, sometimes fatal. Now put a dark-skinned population in Northern Europe 40,000 years ago. Their melanin is excellent at blocking UV. That was brilliant in Africa. But their skin cannot tell the difference between dangerous UV it should block and essential UV it needs. It just blocks. So vitamin D production falls. Bones weaken. Children develop rickets. Women die in childbirth. The population declines, and the algorithm simply reversed its inputs. Mutations reducing melanin appeared, as mutations always do randomly. But instead of being eliminated, they spread. Slightly lighter skin meant slightly more vitamin D, meant slightly healthier bones, meant slightly more surviving children. Generation after generation, slightly lighter, slightly lighter, slightly lighter. For a long time, scientists assumed this happened gradually, a slow drift over hundreds of thousands of years. Ancient DNA demolished that. Early European hunter-gatherers living at northern latitudes for tens of thousands of years were still substantially dark-skinned. The most famous example is a specimen known as Cheddar Man, who lived in what is now Britain roughly 10,000 years ago. DNA analysis published in 2018 suggested he likely had dark to medium dark skin, dark curly hair, and blue eyes. A combination that looks almost contradictory to modern eyes, and simply wasn't 10,000 years ago. The very fair skin associated with northwestern Europe today appears to have spread widely only in roughly the last 6,000 to 8,000 years. In the full 300,000-year history of our species, that is the last few percent. So what happened? Farming happened. When humans switched to agriculture, their diet changed permanently. Hunter-gatherers ate fatty fish, organ meats, shellfish, among the richest dietary sources of vitamin D that exist. Farmers ate cereals, wheat, barley, oats. Their dietary vitamin D didn't drop. It collapsed. Populations that had been getting by on a combination of sunlight and diet were suddenly dependent on sunlight alone. And the pressure for lighter skin intensified sharply. There's a second reason it accelerated. Farming communities were large, dense, and settled. In a scattered band of 50 people, a beneficial mutation spread slowly. In a village of hundreds connected to other villages, it can reach thousands of descendants in a few generations. Diet collapse plus population density hit the fast-forward button. Here's something that surprises people. Skin color isn't controlled by one gene. There's no dark gene and light gene with one dominating the other. It's polygenic. Dozens of genes working together, controlling how much melanin is made, what type, how it's distributed inside cells, how skin responds to sun over time. And this is the remarkable part. Populations that independently evolved lighter skin did not use the same genes to do it. The genetic variants behind lighter skin in East Asian populations are largely different from the variants in European ones. Same outcome, different molecular routes. That's called convergent evolution, and it's one of the strongest signals biology ever gives you. When natural selection keeps reinventing the same solution from scratch, in separate populations, on separate continents, it means the problem being solved really mattered. While we're here, blue eyes. Every person alive today with blue eyes descends from a single mutation in a single individual somewhere around the Black Sea, roughly 6,000 to 10,000 years ago. Before that, the entire species had brown eyes. Blue eyes are younger than agriculture, younger than Stonehenge, younger than the domesticated horse. So step back and look at the whole picture. Skin color, the thing humans have used to sort each other into categories for as long as there have been categories, is, at its biological core, a UV calibration system, a dial. Your body's inherited estimate of how much sun protection you need, based on the latitude your distant ancestors happen to live at and the food they happen to eat. Lighter skin isn't better in any absolute sense. In equatorial environments, it's actively dangerous. More UV penetration, more DNA damage, more folate destroyed. And darker skin isn't less evolved. It's the ancestral state, the original configuration, the baseline everything else is a modification of. If anything, lighter skin is the newer variation. Here's the deepest irony. The same sun drove some populations toward more melanin to survive its power, and other populations toward less melanin because they needed more of its limited energy. The sun didn't pick sides. It radiated indifferently and let evolution sort out the rest. Human beings spent centuries building elaborate hierarchies on top of what is, biologically, a calcium absorption problem and a folate protection mechanism. Every shade of human skin that exists today came from the same population, standing in the African sun, slowly spreading across an unpredictable planet, and carrying, written in melanin, a record of every environment their descendants passed through. Every skin tone is an answer to a question asked by a star. Subscribe if you want more of what your body is still quietly remembering.